Nampa Figurine. You hold a tiny fired clay figure the size of a thumbnail, and the dates tied to it refuse to make sense. Back in July 1889, drillers sinking an artesian well in Idaho pulled up this small statue from 320 feet below the surface. It came up through a column of rock that included a 15-foot layer of basalt, then roughly 220 feet of sand and clay. On paper, that stack of layers suggested an age measured in millions of years. If true, that would push simple fired craftwork far earlier than anyone imagined. But the story is messy. The object is easy to copy, and the way it was recovered makes the context unreliable. Drilling can lift material from many levels. Tiny things can slip into a drill pipe and travel long distances inside the hole. The figure shows iron oxide staining similar to nearby clay nodules, which could happen naturally. Craftspeople in the region made small fired dolls in the late 19th century. Members of the Pocatello community later said the piece matched local work. So basically, what we have is a contradiction: the original excavation notes, and that strange stack of rock push toward a jaw-dropping date. The practical realities of drilling, the stylistic matches, and local testimony point the other way. Scientists tend to favor the mundane explanation, and yet the odd mix of geological detail and eyewitness records keeps this item on lists of impossible objects. Later, analyses tried to date the clay and examine its microstructure with mixed and contested results. What exactly happened down in that pipe, and how the little statue ended up in that layer, is still a tight knot that invites more careful tests. Researchers tried to be scientific about it. Thermoluminescence can date fired clay, but the samples available were tiny and contaminated by the drilling equipment. Tests gave results that people argued over. Some readings suggested a recent origin. Others left a wider range that could not exclude great age. Mineral staining on the surface matched material found in nearby layers. But staining can happen in a lab or in a pipe. That is the core problem. The physical object is simple to describe. The context is far harder to trust. Local testimony pushed the story one way. Craftspeople in the area remembered making similar small figures. Members of the Pocatello community later said the piece matched local work and might have been planted as a prank. That testimony matters because archaeology is not only about objects. It is about people and how objects move through hands and machines. At the same time, the geological notes from the original drilling are oddly specific. A long column of basalt over sand and clay is not the kind of place you expect to find fired human craft. If those notes are accurate, then you have a contradiction that demands a serious explanation. Scientists who study the find agree on one point: you cannot declare the impossible without repeatable, clean tests and solid context. So, what does the Nampa case teach us? It is a reminder that evidence lives in two places. It lives in the artifact itself and in the story of how it was found. When those two things disagree, we get a mystery, not an answer. It is also a perfect conversation starter. Tell someone this evening that a thumbnail-sized statue pulled from a deep well once forced scientists to argue about who moved what and when. Ica Stones. You pick up a smooth, dark rock and see tiny carved scenes that should not exist together. People on horseback, detailed surgical tools, dinosaurs walking beside humans. In the 1960s, a Peruvian doctor started collecting dozens of these engraved stones. Word spread. Soon a farmer named Basilio stepped forward and admitted he had carved many of them with ordinary tools, and then baked them to look old. That confession should have closed the book. Instead, something stranger happened. Not every stone in the collections looks the same. A handful, donated by a local architect, show shallow, weathered engravings of birds and plants that fit pre-colonial art styles. Those pieces do not show impossible animals or futuristic devices. Some stones have surface patinas and mineral deposits that look genuinely old. So you are left holding two stories, One says modern hoax for profit. The other says some artifacts might be authentic, or at least older than the confessed forgeries. Scientists tested the rocks in small ways. The engravings often match knowledge from a later era, like dinosaur reconstructions that reflect mid-20th century ideas. That suggests recent carving. At the same time, the variety in style and wear raises real questions about how many pieces were created when and why. Commercial demand for exotic artifacts can drive fakes. Personal belief can drive denial. The result is a patchwork of evidence that does not line up neatly. So, what do you do with a pile of rocks that tells two different tales? You note where each one came from. You test the surface chemistry. You compare artistic style to known local craft. You follow the money. Even with those steps, the debate lingers, because some stones still resist a simple explanation. Which ones are playthings, and which are echoes of a lost tradition, is a question people are still arguing about. You learn the full story by following the tests and the money. The farmer who admitted carving many pieces used dentist drills and a simple trick to make the engravings look older. He even told people how he baked stones to force a darker surface. That confession explains a large share of the collection. It also explains why many of the dinosaur images match models from the mid-20th century rather than ancient sketches. Still, a few stones sit in museums and private collections that do not display the same pattern. Pieces donated by a local architect show faint weathering and motifs like birds and flowers that match pre-colonial styles. Scientists looked at surface chemistry and mineral deposits on those stones. Some measurements hint at slow formation of patina that is not easy to fake quickly. Other tests, however, show modern tool marks under magnification. The lesson is not a neat verdict. The evidence points strongly toward a market-driven forgery operation for most of the sensational pieces. At the same time, there is a smaller cluster of stones that deserve careful, repeatable testing. The argument becomes procedural. You ask where each stone came from. You test the surface in multiple independent labs. You compare style to known pre-Hispanic art. You trace the chain of custody back to donors and sellers. In the end, this case highlights how archaeology can be gamed and how science can be patient. Some stones are clever forgeries. Some may carry genuine local tradition. Which of those two stories matters more to you? London Hammer. You pry away a hard gray nodule, and there it is, a battered wooden handle and a small iron head trapped in mineral cement. The story begins in 1936, when workers in Texas found a rock with a hammer inside. The rock was said to come from a formation that geologists date to around 400 million years ago. If that context is true, then a simple household tool sits in the wrong chapter of history. People who want a mystery point to that geological column and ask how iron and wood could appear so deep in time. They imagine lost technology or a story that upends timelines. Skeptics answer with a different toolbox. They point out that concretions can form around objects that get buried. Mineral cement can build up fairly quickly under the right conditions and lock a modern object into rock like a fossil. Metallurgists looked at the head. They found iron, heavy corrosion, and a pattern of rust that fits long exposure to moisture. The wooden piece shows signs of weathering rather than full fossilization. The find passed through a chain of collectors and newspapers before it reached careful hands. That matters because context can be lost or confused when something is pulled from a working site. So what do tests actually settle? They show iron and wood altered by time and environment. They do not prove the claimed ancient age beyond doubt. The hammer remains a tangle of strong claim and plausible explanation. Laboratory work tightened the story, but did not close it. Microscopic analysis showed tool marks on the metal that match common early 20th century forging and machining methods. Corrosion layers developed on the iron in patterns that form when metal sits in wet, oxygen-rich soil for many decades. The The wood inside the nodule shows shrinkage and weathering consistent with long exposure, but not with complete mineral replacement. Concretions explain a lot. Under the right chemical conditions, minerals precipitate around a nucleus and form a rock-like casing. That process can trap modern objects and make them look like they belong to a much older layer. Think of a seashell cemented in a lump of beach stone. The lump can feel ancient, even though the shell is recent. At the same time, the original field notes and the local story matter. Items raised during early mining and drilling can pick up bits of older rock and then be described as coming from deep formations. When objects pass through many hands, newspapers, and collectors, context becomes fuzzy. That is why scientists insist on repeatable tests and documented chain of custody. So where does the balance fall? Tests point strongly to a modern origin that was then locked into mineral cement. But the find stands as a useful warning. The earth can trick us. Our own sloppy records can trick us. You are left holding evidence that is compelling but not definitive. Tecaxic-Calixtlahuaca head. You lift a baked clay face from a dusty box, and the first thing that hits you is the profile. The nose is strong, the chin pronounced, and the style looks closer to a Roman portrait than to local terracotta traditions. Archaeologists found the head beneath 3 intact floors in a burial site in Mexico, and the context layers were dated to between 1476 and 1510. That tight stratigraphy is the reason the find still causes arguments. Art historians point out that the modeling and the facial proportions match Mediterranean workshops of antiquity. That resemblance pushes a simple question into the open air. How did a Roman-style head turn up under undisturbed pre-contact layers in Mesoamerica? Skeptics offer other accounts. They ask whether the object could be a colonial era piece that somehow sank into older layers during later activity. They note that trade, looting, and later intrusions can create false signals in an excavation. Scientists call for hard tests. Thermoluminescence can date when clay was last fired. Stratigraphic revision can reassess whether floors were truly intact. Chemical analysis of the clay can point to geological sources. Some labs that looked at the sample reported results that favored a local clay signature rather than an imported Mediterranean paste. Others said that the firing signature did not conclusively place the piece in one century or another. The result is stubborn ambiguity. You hold a face that looks like a stranger from across an ocean. The excavation notes tell one story, the material science tells another. You learn more by following the clay. Labs that tested the material looked for local mineral fingerprints, and for when the clay last saw heat. Thermoluminescence dating can tell when a pot or head was last fired. Some early tests pointed to a firing date within a range that overlapped the proposed pre-contact era. Other labs found a chemistry signature matching local clays, which argues that the head was made nearby rather than shipped from across the sea. Those results sound decisive until you add the human story. The excavation was reported by local teams and later handled by collectors. Looting and later disturbances are common at many sites. A single misplaced object can sink into older layers during later renovations or burial reuse. That possibility undermines any headline claim that a Mediterranean portrait arrived in Mesoamerica centuries earlier. So, where does the weight of evidence lie? It leans toward a local production, influenced by foreign models, or by later intrusion, rather than incontrovertible proof of direct Roman contact before Columbus. The clay chemistry and firing data do not scream importation. The stratigraphy is murky enough that a later object cannot be ruled out. At the same time, the face remains an odd and valuable clue that deserves more careful independent testing. You close the box with the face inside, and one clear takeaway stays with you. Science can shrink some mysteries, but it rarely gives a single tidy answer. Saqqara Bird. You pick up a small carved model, and the first thing that strikes you is the wings, the slim tail, the balance of the whole piece. In a museum label, it may be called a bird model, and explained as symbolic or ritual. Some viewers look at the same shape and notice features that line up with basic principles of flight. Experts who study ancient objects warn against reading modern tech into old art. They point out that many cultures made bird-shaped figures as symbols of the soul or of deities. The form can be stylized and not meant to fly. In that view, the model is a clever piece of carving meant for ritual or play rather than a technical diagram. Other observers focus on shape and symmetry. They note a distinct straight wing, a slight dihedral angle, and a tail that could provide stability. Those are the simple things that help a flying machine stay steady. Amateur researchers and some engineers have built replicas and tossed them into the air to test basic behavior. The results are mixed. Some replicas glide for a short distance, others simply wobble and drop. So, what do you make of that? Is it a toy, a ritual object, or a crude experiment in aerodynamics by curious hands long ago? The scientific path is clear. Make careful replicas. Test them in controlled wind tunnels. Analyze the carving for tool marks and intended proportions. Until multiple independent tests are done, the model remains a piece that teases the idea of ancient knowledge without proving it. The piece pushed experimenters into action. Engineers and museum staff scaled up the design and made careful replicas. They tested them in calm air and in wind tunnels. Some versions slid smoothly for a few meters. Others tumbled and dropped. The difference came down to weight balance, wing shape, and tiny angles that matter in real flight. Museum curators point out where the model was found. It came from a burial context filled with ritual objects. In that world, birds stand for souls and for the sky. That cultural layer makes the symbolic reading powerful. The carving could be a precise symbol rather than a technical diagram. Tool marks and wear often match decorative making rather than design for function. Experimental work did two useful things. It showed that certain proportions can glide a short distance, which means a clever maker might have understood basic balance. It also showed that nothing in the model proves powered flight or advanced engineering. A glider is not a plane. A ritual model that glides a little is not proof of an aeronautical tradition, so where does the weight of evidence lie? It favors a symbolic object with curious aerodynamic properties rather than a blueprint for ancient aircraft. The model teases modern eyes because we know wings and we want to see engines. Practical tests give a sober answer. They limit how far you can push the claim. You fold your hands around the little carving and realize something simple. Surprise is not proof. Curiosity is an invitation to test. Piri Reis Map. You open a faded sheet and read a captain writing notes about sources and charts from older sailors. The map itself is dated 1513, and it turned up in a palace library and re-emerged in 1929. What shocked people was a coastline that some thought matched parts of South America, and even a southern land in a way that did not fit known maps of the time. Cartographers point out a simple truth. The mapmaker wrote that he used many older charts, including Portuguese sources. That explains why the drawing shows coastal shapes that were already in sailors' heads. Projection is messy. Early mapmakers stitched bits of coastline together, and that can create odd matches when you overlay them on modern charts. Other observers focused on a different idea. They said parts of the chart look like a frozen southern land shown without ice. If that reading were true, it would suggest knowledge of a coastline that was not recorded until centuries later. That claim led to heated debate and careful reanalysis by geographers. Scientific work narrowed the field. Scholars compared shapes using mapped overlays and tested whether the apparent match survives correction for projection and scale. Many of those comparisons favored the view that the chart is a composite of earlier coastal knowledge rather than a single miraculous source. The Captain S notes tellingly list maps he used, which supports a slow accumulation of data. So, what do you take from the map? Is it evidence of lost Antarctic charts, or is it a 17th century style patchwork made from older sailing charts? You trace a coastline with your finger, and soon the puzzle changes. Cartographers do not just look at shape. They adjust for projection scale and orientation, and then overlay drawings on modern charts. When you correct for how early mapmakers stretched and rotated coastlines, the supposed uncanny match often loosens and becomes a reasonable fit to known 17th and 16th century knowledge. The mapmaker wrote down sources and names of older charts. That is a crucial detail. It suggests the document is a compilation rather than a single lost chart. Sailors traded sketches and copied notes. Over decades, those pieces accumulated into the map you hold. That slow accretion explains why some sections line up with later discoveries, without requiring impossible voyages. Researchers also tested the chart against different projections to see if the southern land still looked like a coastline without ice. When you account for projection errors and the map maker ES notes the dramatic reading weakens. The apparent Antarctic match can result from stitched-together coastal fragments, and from the map maker S attempt to place distant shores relative to known ports. So, what remains surprising? The map shows how quickly and how well sailors shared coastal knowledge, even when they lacked modern tools. It is a record of accumulated experience more than a single miraculous discovery. The real story is about human networks and the way practical knowledge travels. Which version feels more convincing to you, a single miraculous source, or a patchwork of older charts faithfully copied and combined by a careful, worldly mapmaker, Baghdad Battery? You lift a rough clay jar and see a copper cylinder inside, and an iron rod held within that cylinder. The jar was dug up near Baghdad in layers associated with ancient Parthian and Sassanid activity, roughly 2,000 years back. At first glance, it looks like a simple storage vessel. At second glance, it looks like the simplest possible battery. Scientists and tinkers tested the idea, recreated jars filled with vinegar or grape juice, and fitted with copper and iron, produce a small, steady electrical current. Those experiments repeat across independent teams and show that the setup can generate voltage enough for plating metal in a thin layer. That result is powerful because it moves the object from imaginative claim to experimental reality. Skeptics push back. They note that we have no written instructions, no clear workshop finds, and no consistent set of paired objects that would show a known use. Corrosion patterns on some originals are irregular and could come from stored scrolls or from purely decorative assembly. Museums also point out that small batteries would not power lights or engines, and that electroplating can be achieved at a microscopic scale without suggesting a broad electrical tradition. So what do you do with a jar that can make electricity but comes from a culture that left no direct record of electrical practice? Do you read it as an early experiment in chemistry and metal finishing, or as a clever object that happened to mimic a cell? The experiments prove possibility. The absence of a clear cultural context keeps the question open. The experimental work changed the conversation, but it did not end it. Replicas consistently produced a small electric current when filled with acidic liquids. Independent teams used vinegar and grape juice, and the recreated cells generated enough power to plate a thin layer of metal on a small object. That is a repeatable outcome that moves the jar from impossible claim into experimental demonstration. Still, important pieces are missing. There are no surviving instructions describing how people used electricity. There are no workshops filled with multiple jars or tools clearly designed for electroplating. Corrosion on some originals is uneven and could come from storage or from contact with organic materials. The find sits in a region rich in metalworking and craft, which means the presence of clever artisans is not surprising. It does not prove an electrical tradition on its own, so what would turn possibility into proof? You would need multiple jars in secure archaeological context found alongside objects that show deliberate electroplating. You would need residues and toolkits that match repeated use. You would need written or pictorial evidence that records a technique. Without those things, experiments remain persuasive demonstrations, but not definitive proof of cultural practice. This artifact teaches a modest lesson about evidence. A device can do something in a lab and still be a lonely experiment in history. It can be a clever artisan-esque trick, a funerary curiosity, or the spark of a lost technique. Antikythera Mechanism. You hold a crusty bronze fragment and feel, under the corrosion, the teeth of gears aligned as if in a tiny clock. Divers recovered pieces from a shipwreck off an island early in the 20th century. At first, the corroded lumps looked like junk. Then, researchers began to see gear teeth and inscriptions, and the story changed. What makes this remarkable is not just age, it is the complexity. The device contains multiple interlocking gears designed to model the motions of the sun and the moon and to predict eclipses. Scholars describe cycles engraved on its surfaces. The mechanism tracks lunar phases and long-term cycles used by ancient astronomers. It is a mechanical computer built centuries before mechanisms like it were common in Europe. Modern science unlocked the rest. Researchers used X-ray imaging and computed tomography to peer inside the corroded fragments. Those scans revealed hidden gear trains and tooth counts that no eye could see without technology. Historians and engineers compared the gear ratios to known astronomical cycles and found a striking fit. Some scholars argue it is proof that Hellenistic engineers reached a level of precision once thought impossible for the era. Others caution us to place the device in its cultural context rather than to leap to sensational claims about lost civilizations. Still, the plain fact remains. Here is a working machine that models celestial motion with bronze gears. So, what does it mean for our picture of ancient skill? You watch scans reveal gear trains hiding inside a corroded lump, and the feeling is almost cinematic. Computed tomography showed not just a few wheels, but an entire machine with gear counts that line up with known astronomical cycles. One set of gears tracks the metonic cycle, which repeats every 19 years. Another set fits the Saros cycle, used to predict eclipses. Those matches are not accidental. They demonstrate purposeful design to model the heavens. Epigraphers read faint inscriptions and found technical notes and markings that correspond to functions. Engineers measured tooth counts and ratios, and then built working reconstructions. The reconstructions move. They show that the machine can predict lunar phases and eclipse timings with impressive accuracy. That is proof in the strongest sense. A model that reproduces the predicted outcomes is more persuasive than any hypothesis. Debate continues about provenance. Some scholars argue this is the apex of a local tradition of instrument making, possibly centered on islands where astronomers and artisans work together. Others say it might be an exceptional commission, a single workshop-esque masterpiece created for a wealthy patron. Both views accept the same central fact. Hellenistic hands carved precise gear teeth and understood complex cycles. The broader implication is hard to escape. Ancient engineers achieved levels of mechanical thinking that rival later clockwork centuries earlier than once believed. That rewrites a chapter in the history of technology without overturning everything else we know. You close the report with two possible images, either a buried tradition of tiny mechanical geniuses or a single brilliant device that stood alone. Shroud of Turin. A faded linen cloth folded behind glass, and a faint image of a man who looks like he has been crucified stares back at you. For centuries, people have treated the cloth as a holy relic and as proof of a single famous burial. Modern science stepped in to test those claims. Radiocarbon dating, performed in 1988, placed the cloth in the medieval period, which suggested it was a later creation. That result hit headlines and many accepted it as decisive, but other tests gave different signals. Pollen analysis turned up grains from plants that grow in the eastern Mediterranean. Forensic studies argued that blood stains and the pattern of wounds align with a crucifixion, like the one described in ancient texts. Imaging techniques revealed three-dimensional detail that looks unlike painted shading. Critics of the medieval date point to possible contamination and to repairs that could have skewed the measurements. They ask whether invisible dyes or restoration threads could change the carbon readings. Supporters of the medieval result point out that radiocarbon dating is robust when done carefully, and that extraordinary claims need extraordinary proof. So, where does the weight of evidence fall? It depends on which tests you trust and on how you weigh factors like contamination and contextual history. The shroud sits at the intersection of faith and lab work, and each side brings a different standard of proof. You are left with a cloth that has been studied with modern tools and still divides experts. The research team called STIRP spent long hours analyzing fibers and images under microscopes and with spectroscopy, and they reached striking conclusions. They found no brushstrokes, no pigments that could have made the image in the usual ways. They noted that the image sits only on the very top fibers of the cloth and that it carries three-dimensional information that is surprising for a painted work. Later chemical analysis by other scientists added complexity. Some researchers argued for scorching or thermal transfer as a mechanism. Others explored chemical reactions between body fluids and linen under specific conditions. A prominent chemist named Raymond Rogers later proposed that the medieval radiocarbon sample might have come from a rewoven patch, and that contamination could have skewed the date. His papers pointed to unusual fibers and to chemical markers that he said supported a mixed history. Still, other scholars defend the radiocarbon result and note that independent labs in 3 different countries reached similar medieval ages. They argue that contamination alone is unlikely to move an accurate sample by many centuries. That leaves you with a divided field where method matters and where tiny details shape big conclusions. What would settle the debate? Independent radiocarbon tests on freshly sampled, clearly documented fibers would help. More international blind studies of pollen and textile composition would help. Better reconstructions of image formation that reproduce the exact superficial pattern would help. Until then, the linen remains both a powerful cultural object and a stubborn scientific puzzle. Which evidence matters most to you? Controlled chemistry and imaging, or careful radiocarbon dating that points to medieval origins, Nazca Lines? You stand on a wind-scoured plain, and the lines unfold across the ground like scratches made by a giant hand. From the air, the drawings become animals, straight lines, and trapezoids so large they stretch for miles. The people who made them removed the dark stones on the surface to reveal pale subsoil beneath, and the markings stayed visible because the desert is dry and erosion is slow. Archaeologists mapped the figures and began careful work. Radiocarbon dating of wooden stakes and associated materials suggests the designs were made over many centuries, roughly between 500 BCE and 600 CE. Excavations show that people use simple surveying techniques. Stakes and ropes could lay out long, straight lines and curves with surprising accuracy. What were they for? One idea is ritual. Many researchers argue the lines were part of ceremonies tied to water and fertility. Other scholars proposed astronomical uses and pointed to alignments with certain stars or solar events. Some suggested the straight lines worked as pathways for processions. Recent work using drones and ground-penetrating radar found patterns of activity along lines that support the idea of regular movement and ritual gatherings. The mystery deepens because the drawings are best seen from above. That led to theories about ancient flight or messages to the gods. But practical experiments show the lines are visible from nearby hills and from ground level when you walk the patterns. The real surprise is less that they are beautiful and more that so many hands coordinated on such a massive scale. So, which explanation matters most to you? Ritual pathways, astronomical markers, or a giant communal project tied to water and belief? Recent high-resolution surveys have changed the conversation. Drones and satellite imaging revealed networks of paths and ancillary features that were hard to see on foot. Ground-penetrating radar found shallow cuts and post holes along some lines, which match the positions where archaeologists discovered wooden stakes years ago. Those stakes help explain how builders kept straight lines and long curves across flat ground. Excavations at nearby villages uncovered trash middens and pottery shards that tie the construction to ordinary community life. Radiocarbon dates from stake pits and charcoal place construction across many generations, which shows this was not a single project, but a long-running tradition. That social pattern fits with rituals that recur and with coordinated work tied to cycles such as planting and rain. Environmental research adds another layer. The plain is arid now, but ancient water sources and seasonal streams would have made ritual appeals for water urgent. Some team members argue that the lines served as processional routes that linked sacred places to water sources. Other teams highlight astronomical alignments that mark solar and lunar events, which could have guided ritual calendars. Putting all evidence together, the strongest case is that these were communal projects with ritual and practical functions rather than messages meant for visitors from the sky. The scale tells us about social organization and the value people placed on shared meaning. Yet the lines still look like messages from another viewpoint, which keeps our wonder alive. You leave the plain with one clear thought. Humans coordinated on an enormous scale with simple tools and strong reasons to do so.